Before we begin the video demonstration, I want to point out a couple of things. We've already gone over ledger lines. You should know already the proper notation, the proper methodology. Sometimes in programming, there are limitations to what a program can do. This is an example. If we look at this yellow box here, I've had to use a workaround. Otherwise, it would look like this. That's the first thing. Also, please note, and when we notate ledger lines, we shouldn't add any superfluous or extra ledger lines below or above, above. In other words, this A here shouldn't have any of these above it. The second thing I'd like to cover are parts of this patch. This is a full-size 88 keyboard. When I depress a key, it will change to gray to let you know what key is being depressed. The same for the black keys. This is an oscilloscope which shows a two-dimensional representation of a waveform based on frequency. This is just more information about how a note can be representative: musical, instrument, digital, interface, note. It's mostly used with programming. Frequency is used in scientific, used for programming, science, or as a reference pitch. We're going to count the number of A's on the piano, beginning from the lowest A. 1, 2, 3, 4, 5, 6, 7, 8. In this next example, we'll use one in particular, B flat, or A sharp. This will give you an opportunity to practice your enharmonic notation. B flat, 1 B flat, 2, 3, 4, 5, 6, 7, 8. Octave numbers can be a very useful way to indicate a specific pitch. There's also frequency and MIDI note representation of a note. We'll get to that later. In order to find C on the piano, you notice that the piano has a grouping of 2 black keys, 3 black keys, 2, 3, and so on. In order to find C on the piano, or to find all C's on the piano, you would look at the 2 groupings of black keys, go to the immediate left of that group. That would be the C. C, 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 2 black keys, right to the left of C, 2 black keys, C, and C. This is going to be middle C, the C in between the treble and the bass clef. Let's go ahead and label C, or middle C, with C4. We move up an octave, we see that it moves from middle C, and just follow along here and here. It just continues to go up. I'm only going to play the white keys. The way the pattern works on octaves is that there is a grouping. So we'll go back to middle C. C4, D4, E4, F4, G4, A4, B4, What do you think comes next? If you answered C5, you would be correct. The way this is going to look on your paper, the one that you will use for notes, will be like this. C4, D4, E4, G4, oops, F4, sorry, G4, A4, B4. Let's go ahead and add in C5. So you'll notice here and on your paper, this is going to be a lot of information to put in, and it can get very crowded. As a workaround, I'm going to put it right up here above the keyboard. What I want you to do now is take the time and try and find all the C's and label them from the beginning. If we look at the alto clef, the most commonly used is this right here, centered on the middle line. Wherever the alto clef is, that middle portion is going to be middle C. So middle C would be this middle line, counting from the bottom to the top, first line, second line, third line. This would be middle C up here. It'd be the first, second, third, fourth line on the staff. Find another one, this one is even higher. It's on the fifth line of the staff, so middle C would be up here. This one, middle of the alto clef, is on the second line. So middle C would move to the second line, middle C would move to the first line here, and so on. Let's use the most commonly used alto clef. So here would be middle C. That would be C4. D4, E4, F4, so we have middle C, C4, D4, E4, F4, G4, A4, B4, C5. Here we are at middle C again. Remember, right in the middle of the clef, it's going to be positioned on the line. Here we have middle C again, C4, B3, A3, G3, F3, E3, D3, C3, B2. So to recap, after we label all the C's, every octave group is going to have seven different notes. 1, 2, 3, 4, 5, 6, 7. And the pattern begins with a new octave. First octave, second, third, fourth, etc. Anything before C1 will be notated with a 0. B0, B flat 0, A0. All right, so in our presentation earlier, I mentioned the oscilloscope, hertz, and MIDI note representation. Just as octave numbers give us a precise location of a particular note, just as standard notation would as well, hertz is just the cycles per second that a waveform shows. An oscilloscope is a very easy way to visualize in a two-dimensional fashion a waveform. If we use A, We're going to use A for hertz because it gives us a nice round number without fractions. So you can see this A is going to be lower, therefore the cycles per second will correspond to the lower cycles per second, which will be 55 hertz. As you go up, increasing or ascending to the next octave, the frequency will double. So the next A from 110 would be 220. We go to the next A, 440, the next day, 880, and so forth. Hertz is mainly used for programming, scientific experimentation, or as a reference pitch. Usually orchestras are tuned or use the reference pitch of A440, and the 440 refers to the 440 cycles per second. The MIDI note is another representation of a particular note, in this instance 69. The MIDI note are usually used for programming. That's really all you need to know. I thought this would be interesting. I hope you have a great day.